Hello everyone, I'm Asma and I'll be instructor for today for AS level mathematics. And the topic which we'll be covering today is differentiation. These are the learning outcomes for today's lesson. So let's quickly start. Okay, so calculus is the one of the main branches of mathematics. And what is calculus? Calculus is the mathematical study of change. Now, in the calculus, we have two more branches, derivatives and integration. So you might be thinking where this derivatives or where this differentiation is used. So it is used wherever the change is required. For example, study of population change or to stimulate and predict the effect of diseases like COVID, dengue, influenza. In all of these cases, we take the help of derivatives. Derivatives, this differentiation has been invented by Newton and Leibniz, and later Lagrange and Euler has formalized its rules and applications. So Lagrange and Euler has a very major role in the differentiation. Okay, so now let's quickly come towards its conceptual part, that how to find the derivatives. Okay, let's uh, quickly look towards an example, towards a problem. For example, I have a straight line and I need to find its slopes. Okay, this is point A, this is point B. A is 1 comma 2 and B is 3 comma 6. So what is slope? Slope is delta y over delta x. Change in y over change in x, which is 6 minus 2 over 3 minus 1, right? This is the slope of this straight line. What if I ask you to find the slope of this curve, or to find the slope of this curve, or to find the slope of this curve, right? So you might be thinking that where will we take 2 points because this is a curve, this is not a straight line. So in such cases, what we do is we take the help of derivatives. Okay, since slope needs 2 points, so our 2 points in our case of finding derivatives will be x and x plus h. As you can see in this picture, this is our first point x, this is our second point x plus h. X is far, x is at the distance of h from the second point, say the x plus h. Now our aim is to bring this second point so much closer to this x, bring this second point, bring this second point so much closer to this first point so that we may find the slope of this curved, of this point present on this curve. So since our aim is to bring this point closer, so hence we'll be taking our h tends to 0. This this slope which is calculated by considering that h tends to 0 is also called as instantaneous slope or the derivative. So again, it's written over here also that we're bringing the second point closer and closer to the first point. We shrink this change until it almost becomes 0. So I'm repeating again that this is our first point x, this is our second point x plus h at the distance h. Our aim is to bring this second point closer to the first point so that in this way we are finding the slope of this point on the given curve. And since we are bringing it closer, that's why we are taking h tends to 0. Okay, so there this is the first principle of differentiation, which is limit h tends to 0, fx plus h minus fx upon h. Again, if you can relate it with the formula of slope. So the change in the second point minus the change of the first point, since it was delta y over delta x, right? So in the similar way, you are subtracting second point minus the first point. Second point was x plus h, first point was x. So f x plus h minus fx. In this way, you are getting this one. This was the second point, and this was the first point, right? And this was the distance between them. There's one more way of writing this first principle, which is x plus a minus fa upon x minus a. Here, h is equal to x minus a. And here as well, is x tends to a will also will be taken to 0, right? Okay, so this is the first principle, which is you need to remember it, and we will be solving one example as well by the help of it. Let's quickly go towards that example first. Okay, okay, that first principle which I just showed you, it is also called as ab initio method, or you can say first principle. Fine. Okay, so let's quickly start the question with this. We need to find a derivative of this first principle. Fx is equal to x squared. Now, since this is the first point, right? We need to find the second point. So our second point will be x plus h whole square. Okay. So what was our formula? Our formula was f x plus h minus x. Second point minus the first point. So our derivative will be f dash x is equal to second point minus the first point. Okay, let's quickly open it. Since we know the formula of a plus b whole square, so therefore it is x squared plus 2xh plus h squared minus x squared upon h. We'll further simplify it. We'll simplify it. This x squared with x squared will be cancelled. Okay, so we'll take h common from above. So it will be 2x plus h will be cancelled. Okay, since h was approximately equals to 0, So in this way, the derivative is 2x, right? This is our required answer. So let me explain you again. We need to find the derivative of x squared by the first principle. Our first principle of derivatives say that second point has been subtracted from the first point. So it was at the distance h. Second point was at the distance h. So it was x plus h whole square minus the same function x squared. We opened this with the help of our algebraic formula. X squared plus 2xh plus h squared minus x squared. These two terms will be cancelled, and in this way we got our final answer. Now let's move on to our rules of differentiation. We have some basic rules of differentiation. The first is called as power rule. D upon dx, x to the power n is equal to nx n minus 1. Okay, this is a very important formula, the first base of this whole topic. Let me explain you with for a few more examples. Before this, just want to clarify these two ones. Constant rule. What is constant rule? For example, if you are taking a derivative of any constant number, the answer is always zero. Okay. And what is constant multiple rule? For example, you need to find the derivative of 2x squared. So what you can do is you can bring this 2 back and you can just find the derivative of x squared. And then in the end, you can multiply these two answers. Answer of d upon dx squared multiplied by 2. So let's quickly go through it in this example. Okay. So for example, let me explain you first the power rule. What is power rule? Then we will solve these four problems. Power rule says d upon dx x to the power n is equal to nx n minus 1 d upon dx x, right? For example, I have the question x cubed. I need to find its derivative. So what is n here? 3. So according to the formula, 3 will come down x 3 minus 1 d upon dx and only this base value, which is x. It will be 3x squared, and when you are differentiating the variable with itself, the answer is always 1. Why 1? Because if you will apply the power rule over here, so it will become 1 dot x 1 minus 1, which is equal to 1 dot x to the power 0, which is equal to 1 dot 1, and it's equal to 1. So we will just learn this, that d upon dx is 1. Whenever you are differentiating any variable with itself, the answer is always 1. And the concept behind it is this. So the answer is 3x squared. Let's look at our second example, part B. It was part A. Upon x4. Okay. What we can do is we can bring this power upwards. Okay. And we can inverse it. Now, if so, d upon dx, x to the power minus 4. Now again, I'll apply the power rule. The power rule is nx n minus 1 d upon dx x, right? So it is n x n minus 1, right? And this d upon dx is already 1. So it is minus 4x to the power minus 5. Or you can also write it like this, that it's minus 4 upon x to the power 5. Or you can write it like this, minus 4 upon x to the power 5. Okay, so this is our required answer, and this was answer of part A. Now let's come on to our under root x, square root x. It is our part C. So again, d upon dx. Okay, so what is square root? Square root is 1 by 2, right? So again, our power rule says nx n minus 1. N x n minus 1. Okay, d upon dx x. So if you're gonna solve it, so the 2 will come in denominator and it's 1 minus 2, which is minus 1 by 2. So you can write it as 1 upon 2 x to the power minus 1 by 2, or you can write it like this, that 1 upon 2 x to the power 1 by 2, or you can write it like this, 1 upon 2 under root x. So this is our required answer. Okay, again it's just nx n minus 1. Now let's come on to our last one, 3. If I want to differentiate a constant number. So as I told you before, whenever you are differentiating any constant number, the answer is always 0. But if there is any variable with it, you need to apply the power rule on it. Okay, so this was all about the basic rules of differentiation. Let's come on to the conclusion part of any question if it's given to you and they're asked you to interpret the gradient. For example, you found a answer. Now they're asking you to interpret the graph, the curve. So if the curve is increasing, going upwards like this, the first one, it's always in this form, the upward form. So that means it is increasing. And it is the downward form. All these are negative gradients. So that means it is decreasing. If it's a straight line, then its derivative is always 0. And large magnitude has very steep slopes. Okay. Okay. So we are done with our first question, and let's come on to example number 2. The given is y is equal to x square minus 4x plus 5. You have to find the gradient of the curve at x equals to 3. Interpret the gradient as well. Now here we will use our differentiation as a tool to find an equation, and then we'll put in it x equals to 3 to find the exact value. So let's start first. You need to find the derivative of y. So dy by dx is equal to d upon dx. I'm writing the differentiation with each term separately. Okay, so it's dy by dx 4x plus dy by dx 5. Okay, so in the first term, we will be applying the power rule. N x n n x n minus 1 d upon dxx, which is 1 minus 4 will be taken out. And for this one, this x, so it is n x n minus 1, again d upon dxx, plus, and derivative of the constant is always 0, right? So it's 2x minus 4, it's x naught. That's 2x minus, this is equals to 1, right? This part. So it's 2x minus 4. This is our uh, general form. Now, if I need the answer at x equals to 3, what I'll be doing it, I'll plug in the value of x in this equation. So it will be 2. In the place of x, I'm writing 3. So it's 2 3s are 6 minus 4, which is 2, right? They also asked to interpret the gradient as well. Now for interpretation, I told you since the value is greater than 0, the graph will be in the increasing manner, right? The graph will be for in the increasing manner. As I showed you over here, this was for the positive gradient, this was for the negative gradient, this was for 0 and large magnitude. Okay, so you can just make a rough graph for it just to show that you got a positive gradient. Okay, so now let's come on to our example. Okay, so we are done with the example number 2. Now let's come on to example number 3. Okay, so the question says let P be the point 2, 4. These points also lie on the curve and are close to the point P2, 4. First, they're asking to calculate the gradient of chord PA, chord PB, and chord PC. So again, a chord is a straight line. So as you all remember how to find the slope of a straight line, right? So it's PA. So since P is 2, 4 and P is 2, 4 and A is 2.2, 4.84. So it's 4.84 minus 4 upon 2.2 minus 2. Similarly, PB, it's 4.41 minus 4 upon 2.1 minus 2. And for PC, 4.0401 minus 4 upon 2.01 minus 2. So I can use my calculator to calculate these values. So it's 0.84 upon 2. So it's giving us 4.2. Similarly, over here, 4.41 minus 4, and you're gonna divide it by zero point 0.1. So it's 4.1. And similarly for this one, 4.0401 minus 4, and you're gonna divide it by zero point 0.01. So it's 4.01. Okay, so suggest a value of the gradient of the curve y is equal to x squared at the point. So now since for a straight line, this was a simple method. Now you need to find a gradient of the curve. Okay, so now for the curve, what you will do, you will take the derivative of this x squared. Okay, again we will apply the power rule. N x n minus 1 d upon dx is x. So it's 2x is the derivative of the curve. And since they're asking at the point 2 comma 4, so at the point 2 comma 4 our x is equal to 2. So if we plug in the value of 2 over here, so it's 2 2s are 4. So this is the required value of the derivative of the curve. Okay. Okay, so we are done with these example questions. Now I hope this is clear. Uh, okay, so representation is concerned, as far as representation is concerned, so it is the differentiation is represented as dy by dx, as f dash x, and as d dash. These are the three representations. You can represent in either of the way. Okay, so let's come on to our conclusion part. That what is derivative? Derivative tells us the instantaneous rate of change, gradient at a point on the curve, and tells how fast something is increasing or decreasing. Just by looking at the value, just by looking at the value, you can predict whether it is increasing or decreasing. So that was all for today from my side. We will be looking at few more questions and more concepts in our next lesson. Thank you.